So for this afternoon, we'll be discussing work and how you're going to mathematically model using integral calculus worded problems concerning work. Now, let's first discuss the learning objective for these sets of slides. So for our learning objective, you as students are expected to be able to calculate the work done by a variable force, the work done by springs, and the work done in pumping fluids. Now, the first one, calculating work done by a variable force, is closely related to finding work using your physics, but in the case of physics, there your force is fixed. It's constant, it's not variable. So in the case of calculus, we're going to extend further the concept of this force to something that is varying. That is, it's not constant, it changes. So that is why it's called a variable force. But the thing is, the formula that you're going to use is pretty much the same in terms of form to the formula that you have already learned in physics regarding work. So again, work in physics is work wherein the force is constant. Work in calculus is work that is not limited to a constant force, but rather a force that is changing. Okay? Now, as to spring work, you also have this in physics. Hooke's law. I hope you can still remember Hooke's law. You have your physics in senior high. You have your physics in junior high. You even have an extension of physics just last sem. So this Hooke's law is the work done by the spring. But in this case, again, the force is variable. So vary siya, hindi siya constant. So you have now calculus to help you find this work when the force applied is not constant. So in the case of variable force, in the case of work done by spring, the force applied are all changing. In the case of the work done in pumping of fluids, if a fluid is being pumped from one location to another, corresponding amount of energy is utilized in enabling that particular amount of solid to be transferred from one level to another. In here, calculus will help you how to find this or calculate this amount of work in pumping a particular amount of fluid. Okay? Now, so those are our three objectives. So we will go along, we will process this as we go along. Our target this afternoon is at least cover the first two. If not, then we will just continue with the rest next week. Now, you've learned in physics that if the force of magnitude F is constant, if you're going to determine the amount of work done by this particular force in displacing an object from one particular location to another, and this displacement is given or represented by D, your physics then discusses work as or uses the formula force times the distance. So work done is equal to the force applied to displace the object d distance or displace the object d distance from its original location. So this is your formula in physics. Simple formula in determining work done by a force of magnitude F, but take note, here it says constant. The force is constant. And the object is said to be displaced by distance D. So this is our formula for that. Now, what about if we have a different scenario? So that before we go to that, so these are examples that I placed in here regarding work done by a constant force of certain magnitude which displaces an object d distance from its original location. So an object moves 5 feet along a line which or while subjecting to a constant force of 100 pounds in its direction of motion. So take note that the force is 100 pounds and the object moves 5 feet along the line of the direction of the force. So the displacement of the object, by the way, has to be along the line, the direction of the force. So if the force is horizontal, the movement of the said object has to be horizontal. That's a requirement in physics. The displacement has to be in the same direction as the direction of the force applied that causes the displacement. So in this case, your displacement of 5 feet is in the same direction as the direction of the force applied, which is 100 pounds. So very simple. Physics tells you that you just simply need to multiply 100, the constant amount of force, and the displacement, which is 5. So 100 pounds times 5 feet is 500 foot-pound force feet, or feet pounds. So this particular unit, set of units for work is English. The displacement in feet and the force in pound force. So this is to be assumed to be pound force, because we know as well also in physics that when we speak of pounds, it could either be pound mass or pound force. And you need to convert one to another. If it's really written as pound mass, then you have to convert it to pound force using the G and the G sub C, which is, I'm not going to discuss it anymore because that's your physics. Now, what about if we have a sample problem using SI set of units? So second problem, an object moves 25 meters along a line subjected to a constant force. So take note that it's always specified, class, that your force is constant. Here also, it's specified as constant force. So the displacement is 25 meters and the constant force is 4 newtons. So work is just the product of the force and the displacement. So your force is 4 newtons and your displacement is 25, giving you answer of 100 Newton meter. So Newton meter is equivalent to joule. So 100 joules for the second answer to the second, for the answer for the second problem. These examples are easy because your force is constant. Okay? It's constant in the direction of the displacement of the object. For example, you applied a force horizontally, but your object was displaced vertically. Is there work done by that particular force? Your force is, the force applied to your object is horizontal in direction. The displacement of the object is vertical. Do you have work done by the force on the object? Or is work done by that horizontal force on the object? You can place your answer in the chat box. The force is horizontal, the displacement is vertical. Do we have work done in this case by the force that is horizontal? Class, are you there? Okay, one answered yes, the other said no. No, yes, no, no. Okay. There are those, a lot answered yes. So my question, I repeat again. The force is applied horizontally on an object that was displaced vertically. My question is, was work done by the force that is acting on the object horizontally? So there were a lot who said yes, but there were a little who say no. So I'd like to ask Christine, why did you say no? Why is it that work done by the horizontal force is 0? Why you say there is no work done by the horizontal force that was displaced vertically?
Kaya hindi sila in the same direction.
Very good. So for those who said yes, I don't know what happened to you in your physics class. Maybe you were asleep or you didn't really grasp the principle at all. Even if the object is displaced, class, it doesn't follow that the force that was applied on the object was able to do work on it. The very important requirement for work to be done by a particular force on the object is this, that the direction of displacement and the direction of the force have to be the same. So when I said a while ago, your force is horizontal, the object was displaced vertically. Ang iya movement hindi horizontal kundi vertical. So ang pamangkot ko, may ginubra nga work ang force nga horizontal. Of course, the answer is no. The work done by that force is zero because the object, though was displaced vertical. Requirement na iya sa work na dapat ang displacement kag ang direction sang force should be horizontal. So that same principle, class, will be applied in here in calculus. So if you're not able to grasp it in physics, 3 times, you already took physics 3 times and you were not able to grasp it in here, dapat diri sa calculus, dapat ma-sink in na gina sa inyo nga consciousness nga requirement nga dapat pareho direction ang force kag ang displacement. So whether that force is constant or nagavary, kung ang displacement ng object hindi the same direction sa force applied, wala sang work nga gin-apply, wala sang work done, zero. Okay, I hope you get it. So in that case, the answer is no. It's not a yes. Okay, now we will proceed on the next slide. So this is just a review of the concept of work from physics. That it's equal to force times the displacement. Requirement is displacement and force direction has to be the same. Now, what about work done by a variable force? This time, the force is not fixed at 100 newtons or 25-pound force. No, it's not fixed. When we speak of not fixed, not constant, it's an expression. It's a function of something. So then, that particular function of something should replace the F in the formula of the work. So as what is written here below, suppose that an object moves in the positive direction along a coordinate line while subjected in a variable force f of x. I'm saying it's f of x because your force, which is varying, changing, is a function of x that is applied in the direction of the motion. Now, there's a need for you to define what is meant by the work W here. Performed by what? By the force on the object as the object moves from. Oh, take note, we have already a set interval here. The object moves from x equal to A to x equal to B and find a formula for computing the work. Now, if you are wondering, saan una siya miss kakatabo yahaw nga ang imo force hindi constant, kadamo sang scenario nga hindi constant ang gina-apply na force. For example, we'll just use this spring. And we want to use this illustration of the spring to illustrate that the force applied to perform work on a particular object, to displace it in the direction of the motion of the force, is varying, meaning it's either it's increasing or either it's decreasing. Now, this is, let's say, your A position for the spring, the natural position of your spring, wherein you have attached a block. This is, shall we say, we'll assume this is the unstretched position of your spring. Isn't it that when you move this block, initially you will apply a force here? Now, where is the force greatest? In the initial movement or of the block, or in the farthest most portion, displacement of this block, wherein you have a string attached? Diin dako ang force in-apply mo. Sa sugod pa lang, magingiho mo ang block, o kung nang lapit na ni mag-straighten ang ini nga spring, o, diin ang dako nga force gin-apply mo. Initial or final? When do we say that we are applying the greatest amount of force in this block? Or shall I say, simple question na lang, not when, but rather, is the force that you're applying on this block constant all throughout the time that you are stretching it? This one, the block that is attached to the spring, this is unstretched position. It's attached to this spring, unstretched. Now you move the block. Is the force that you're applying on the block to make it continually be displaced in this direction constant at all times? Not constant. No, miss. Thank you. Thank you. At least may tatlo na nga nagsabad sa akon. Kala ko ako na lang isa de. The force that you are applying on this block to have it continually displaced. Gusto mo siya bala i-displace? Mahalin di siya, oh. Hindi mo siya pagbuyan. Do you think parariho lang ang force na gina-apply mo? Hindi. Sa sugod, okay pa na. Pero as the stretching of the spring increases, you will tend to apply more force to keep the block moving. If not, it will go back to its original rested position. So this is just an example. I'm just using this one as an illustration, not that this is the work that we're trying to compute here. This is an illustration wherein the work that you are applying is not fixed. It's not constant. In this case, you need to apply more work to keep the block moving. If not, if you decrease the amount of force that you're applying on it, then the block will tend to, of course, go back to its original position because of the springs that hinders it. Okay, there is this force here, but it's a totally different case of work in here. But nonetheless, this is a scenario wherein the force that you are applying on the block is not constant. So if you wanted to pull the block attached to the spring horizontally, then we would have to apply more and more force to the block to overcome the increasing force of the stretching spring. So the answer to my question is actually in here. The force that is being applied to keep the block moving is increasing. Now then, how will integral calculus help us set up the equation for us to be able to determine the work done in pulling an object, or let's say moving an object in the direction of the force for a force that is not constant? This is now our formula. So suppose that an object in the positive direction along the coordinate line over the interval a to b, well, subjected to a variable f of x that is applied in the direction of the motion. So the object moves in the direction of the force. So take note of this. Positive direction along the coordinate line over the interval a to b. So this interval a to b now comprises the limits of your integration. The force that is not constant, the force that is variable, is written here as f of x. It's a function of x. What is x? It's the displacement of the object from its original position. So in this case, your force applied on the object is a function of its displacement. This f of x is a function of the displacement x, which is bounded by the interval a to b. Okay, so this is now your integral equation. So in cases wherein you are to use calculus, specifically integral calculus, to determine this work, then you need to identify first what are your limits of integration, and importantly, what is the expression for the function of x. How will you write down the function of x? That way, you will have a correct calculation of the said work. Okay, for you to understand me better, I will give several examples, but for now, do you have any questions? Okay. Sige, none. So we will proceed. Example 1. A 60-meter climbing rope is hanging over the side of a tall cliff. How much work is performed in pulling the rope up to the top where the rope has a mass of 66 grams per meter? Now, second question, how much work is performed in pulling a 60-meter climbing rope up a cliff face where the rope has a mass of 66 grams per meter? Now, I'd like you to understand, read again silently the problem and the two questions specifically. You may wonder why, how come the two questions, they seem to be the same. They seem to be the same, but actually they're not. So I'd like you to read it silently and tell me the difference. Tell me first your understanding of the problem. You can speak in Ilonggo. Then tell me the difference of the two questions. How much work is performed in pulling the rope up to the top where the rope has a mass of 66 grams per meter. So it's a 60-meter climbing rope. The second one is how much work is performed in pulling a 60-meter climbing rope up a cliff face where the rope has a mass of 66 grams per meter. Okay, I'll give you around 2 minutes to process the problem. Oh my. So I was not able to record it a while ago during the break. Anyway, ano lang tong na-record ko.